And it is time for the highly anticipated K-PAC competition. So excited to see what happens here. And you will have the opportunity to vote. That will come in polls. So you see the pop-up and we want to get your vote. So now I'll just would like to introduce Josh
Yeah, will you
Kullis
turn that
from
off?
So excited to see what happens. You're on, Josh. Hi. So you're gonna go ahead and take it from here, right? So now
Yeah.
you're all, yeah, perfect.
Sorry about that.
No problem.
Okay. Thanks for the introduction. So if you're not familiar with the Cool K-PAC competition, we've done it now for the past 5 years. And the idea is that we want to go out, we want to find different ways that organizations are using knowledge packets. They're putting them into assessments, collecting information. So we kind of canvass customers, we solicit entries into the contest, and then we select 3 finalists. So we have our 3 finalists here this year. We'll kind of go through each one of their knowledge packets. They'll actually present the use case for the knowledge packet. And then at the end, like Amy said, we're going to put up a poll, we'll vote, and the winner will receive the knowledge packet trophy that's behind me on the shelf. So why don't we get started? Our first finalist is Susan Bachmann from General Motors. Susan is a manufacturing requirement system lead and manufacturing engineering Auros administrator. And she is going to walk us through her knowledge packet that will calculate the maximum achievable weighted scores for an audit assessment. Susan, take it away.
All right. Thanks for the intro, Josh. I am honored to get to kick off the Cool K-PACs today. So this one I brought in for the conference about a year ago. One of our stamping engineers, Paul Hillman, hopefully he's made it on the call to see this. He suggested moving one of their existing processes that was an Excel-based checklist into Auros. And it's basically an audit of some guidelines across 16 different categories that's done annually at our stamping plants. And each of these categories holds a different weight. So for example, one of the categories is guidelines related to cranes. And maybe there's, 10 questions in there, and that section is worth 5% of the overall score. And then we have another section for guidelines related to blank receiving that's worth 10% of the overall score, but maybe it only has 3 questions in there. So we have to incorporate some calculations to get those weights comprehended in our scores. But then he also had this extra challenge in the existing Excel file in that it would calculate a maximum achievable score. So some of these guidelines are a little bit newer, and maybe some of our older plants, they physically cannot meet this guideline. So we've kind of grandfathered them in. And so we have this maximum achievable score, which is, for the ones that they can meet, how are they scoring, right? So that's how this K-PAC came to be. This is one of my personal favorite K-PACs in manufacturing engineering. And what it's going to do is it adds up the lines, the questions that were met in each category, and the category is abbreviated with a 3 or 4 letter code. It adds up the lines that were met, divides it by the count of the lines that were even achievable, and then multiplies it by the weight for that category. So you can see these different categories all have different weights. And then the output is the weighted maximum achievable score for that category. And then this cool K-PAC feeds a more boring K-PAC that basically just adds up all of these scores and spits out a weighted max achievable score. So we need to take a look at this in an assessment to really see it work, because the answers to all of the questions drive these values in the parameter table that then feed into this cool K-PAC and provide the numbers. So here is our K-PAC ID that we were just looking at in an assessment. That's the value table that we saw when I had the K-PAC open. And then these are all of those values that it's calculating. So if we look down below that, we see these are the K-PACs that add up the scores. And right now with the audit the way it sits, we're at an overall score of 81.4, but if we're only looking at the lines that they can achieve, we're at a little over 89%. So I'm going to scroll up to the actual audit sections here. And you can see they're all broken into the different categories. And I'm going to expand the one category called weld area and support equipment. And that's a mouthful, so I'm just going to call that WAYS from now on. And you can see there's 6 audit questions that fall within that WAYS category, right? So we're going to play with this one, this question number 40. And normally the user would actually see a question over here, but I've put the value table here so that you can see where these numbers are coming from. Right now it's set to yes, and then the value table pulls in these values for the score and the 2 different types of counts, right? Our parameter names and the value tables are consistent across all of these questions. So I think there's about 97 or so questions total in the audit. And the format is always this K number and then the category and then what it's adding up. We formatted it this way so that when we do a sum across the category of either the scores or the counts, we can just throw a star wildcard in there and use a sum function, which is pretty simple. So that's the naming convention here and what all that means. So what I'm going to do is change the value on this so you can see how it works. And the way that the users would answer these questions is click on the rule processor. And I'm going to change this to no, not achievable, and let it evaluate and close. And you're going to see the line automatically changes to red because the value table knows that that's the fail condition. And our numbers have updated accordingly. So now the score is 0, but it's not going to count it in the KPACs that can be achieved. So I need to reload the page to see the effect on the scores. And this takes a minute because it's crunching a lot of numbers. It's got, over 100 value tables that it's got to work through. And then I'm going to go down and look at our cool KPAC, which was 124. For that WAYS section, we're at 0.05. And then these are the weighted scores. So our overall score has gone down because we added a line that we didn't meet. But our weighted score our maximum achievable score didn't change because we can't meet that line anyway. So then if I go back up and change it to achievable, and while this is crunching, I'll just kind of recap really quickly. So there's 97 questions, 3 answers. You met it, you didn't meet it, can't meet it. That sets these scores and count values on each question to either 1s or 0s. And then we have a series of non-scorable KPACs that add all of those up, and then other ones with formulas that take into account the weights and whether it was achievable or not. So again, here's our cool KPAC. That WAYS weighted score for max achievable has gone down. And then as we would expect, the overall score stayed the same because it was a fail before and it's still a fail. But when you're looking at the maximum achievable lines, it also went down because we're saying that is achievable and we're not meeting it. So that's how we're using a KPAC and value tables to calculate weighted max achievable scores.
Thank you, Susan.
Thanks.
All right, our next finalist is from Spirit AeroSystems, presented a little bit earlier today, Darwin Peterson. Darwin is the Tools, Processes, and Governance Manufacturing Engineer, and he is going to talk to us about using sets to optimize the use of knowledge packets.
Okay, can you see my screen?
We can.
Okay, so this is a follow-on to some things I just mentioned a little bit ago in my presentation, but there's lots of ways to represent knowledge. This is focused on value tables in KPACs and sets. So how to leverage the sets to optimize the KPACs. You're looking, of course, for clarity of cause and effect. You can say as long as you get the right answer, there's no wrong way, but try to make things clear. How frequent the frequency of change, how often do you expect change to happen in this domain? And what are the numbers of rows and columns that you need to accomplish the desired output? All become things to consider. From a process execution perspective, like you've seen in my presentation, you might need a lot of things at the same time. So they might be directly related to each other. They might be independent in and of themselves, but at the level that you want information might be related together. All of that can be accomplished with a set. So when you can do it together, saves a lot of time and calls back and forth from the applications. And you can accomplish things like internal logic from one K-PAC to another. Here's a quick just abstract representation of that idea. So one approach is you could put all of this in one K-PAC. Let's say you got 6 inputs and 8 outputs, and these happen to be the combinations inherent. You end up with 48 rows. But if you broke them up in 4 K-PACs and you have this smaller, clearer association and only a few rows in those, you end up with only 11 spread across 4 K-PACs. So we try to do that wherever we can because for the reasons mentioned. One, clarity of what something means. You can combine it. When you start getting lots and lots of rows, it's harder for somebody to interpret, find, and maintain content. Okay. So this is the one that we're going to look at. It's got a lot going on inside of it. Some, as you can see, feed others. Outputs become inputs to others. Some not stand on their own, but all of the content was needed at that point from a logical processing perspective. So now I'm going to jump over to try to get to where we want to take a look at this. Get to the right one. Okay, so this is the set. You can see that content in there. If we test it and run it here, we get this content out. Processes evaluations for lots of different tools that are related to be able to perform it. The calculation of the specific fastener. In this case, you have a bolt that's being installed. If I change this to something that's going to give me here, we have a rivet. Its output. So that's the kind of thing that we're doing in this scenario, and try to optimize the K-PAC design, leveraging the use of the set. And that's that.
Thank you, Darwin.
You bet.
All right, and our third finalist for this year's Cool K-PAC competition is Chris Pizzo. Chris is a quality chain engineer at General Motors, and he's going to be talking about a knowledge packet that documents the process workflow. Chris, take it away.
All right, thanks, Josh. Great job, everybody. Really wish I didn't have to go third. Great job. So today I'm going to talk about how we use method K-PACs at GM. So what I'm showing here is a fairly basic process workflow that we use. So we have 6 different valves that are at different times throughout the vehicle development process. Each one of the valves in the method K-PAC has a dynamic K-PAC set linked to it, which allows us to always have the most up-to-date templated K-PACs in the assessments that are going to get created. There's also a checkpoint flag for each one of the valves as well. Here we use relative offset dates to generate required completion dates for those different valves in the process. As just a method KPAC, it's a pretty basic method. It's just a workflow. But what makes it a cool KPAC, in my opinion, is what we can do with the Auros batch jobs and APIs to put this into assessments. So we use the Auros batch process to automatically create assessments with this method KPAC linked to them. So the master assessment, as it's called, gets automatically linked to a team board based off of the batch job, and that ties that assessment to a particular project. And then we get a screen that looks like this. So once we're tied to a project, the checkpoint flag dates are now project specific. So we get required completion dates that are specific to whatever program we're looking to work on. We used Auros APIs to auto-generate the assessments for each one of these valves. So using the extended elements of the KPAC, we can use GM gold source data to look into the method and assign a DRE, a SQE, or supplier quality engineer, a validation engineer to the assessment. It automatically creates the assessment with a dynamic KPAC set and sends out an email notification to that user, notifying them that they have work to do. So as Josh was showing, as these assessments get created, they automatically link to the workflow. And then you can see in Valve 3, for example, we have the ability to create multiple assessments through that API by DUNS. So according to by DUNS, we can add different suppliers that can access the assessments through the partner portal. And then the engineers are also able to access the assessment like what Josh is showing here. You can see that for that particular assessment he was just hovering over, it gives a pie chart of what the status of each KPAC is within the assessment and an overall status of the assessments. And then as these assessments are getting completed, it also updates the checkpoint flag. So in this example, the assessment is incomplete. And if you hover over the Valve 2 checkpoint flag, Josh, the plan date or the required completion date of the assessment was August 20th, 2021, but that particular assessment was completed on the 19th. So the checkpoint flag automatically updates to green. And if they completed the assessment, but it was completed late, it will go to yellow. And then if the assessments have not been completed, but is past the required completion date, like in the Valve 4 example, the checkpoint flag will be red. We can use this data to pull reports to show by program and by component or commodity which of the valves are complete, which ones are late, and who owns those, so we can ensure that the process is being followed and completed. So that's all I had, Josh. Thank you.
Right on. Thank you, Chris. All right, so those were the 3 finalists for the Cool KPAC competition this year. I think the next thing that we're going to do is open up a poll. There's an option for each of the finalists, and in that poll, we're going to vote for who has the coolest KPAC. I think there's a little bit of a delay on my screen, but the poll should be coming up over on the stage tab.
Yep, the poll is up now, so we'll just kind of wait. Do you have the results there, Josh, or do you want me to kind of monitor that?
I have them, but I think I am behind. So
for me to see them, I have to vote, which I'm guessing you don't want me to. I don't want to skew. So are you seeing it though? The poll question, Josh?
I do see the question. Yeah.
Okay.
Yep.
But do you have to vote in order to get the results?
I do not. I can see the results.
Okay. Oh, perfect. Then
Yeah.
you're set. I'll probably just go away until you're done. Thank you.
So far we have 37 votes. So it looks like we've got about 90 people in. So if you do go over to the panel on the right and go to the stage tab, and underneath that, there's a secondary tab for polls. The Cool K-PAC competition is there in the polls. We'll leave that voting open here for a few more minutes. While the voting is open, I think maybe we can go into the introduction of what we plan to do in future conferences. So we've talked a lot over the last couple of days about this kind of drive toward assessment first. And one of the things that we're looking at is kind of, you've seen Cool K-PACs. All three of our presentations today really talked about what they do in assessments, or how they interact with the actual use and the application of the information that's there. So the Cool K-PAC competition has been something that people really like a lot as we start to drive towards this assessment first concept and start looking at the assessment and then delivering the knowledge packets into it. A lot of things are the same as what we've done in the past, but kind of changing the communication, changing the orientation is something that we've started to do here within our organization and with a lot of our customer sites. So our plan next year is to kind of pivot from the Cool K-PAC and start talking about workflows and assessment processes. So we haven't quite come up with a name of what the contest will be next year. The Cool K-PAC kind of just flows pretty well, and we haven't quite come up with something that's similar to that. But the plan next year is to look at workflows and assessment use and kind of see what different creative ways companies are using assessment controls. All right, so we still have the poll open. How long do we want to leave the poll open for, Brittany?
It looks like she's saying proceed.
All right, so we have a total of 53 votes, it looks, and the winner of this year's Cool K-PAC competition is Chris Pizzo from General Motors. Congratulations, Chris.
Yay.
Thanks, everybody.
Good.
Well, again, we appreciate everyone's entries into the competition. Appreciate the finalists for spending their time with us here and presenting their knowledge packets. Congratulations to all of you, and we look forward to the competition next year.